Welcome to Student, a series of animated calculus videos that will help you prepare for the AP exam. These videos were made by students for students.
Today we will be looking at the formal definition of a derivative, topic 2.2. And remember, as Larue always says, you do you, boo. So in order to grasp the formal definition of a derivative, as a recap, we'll be looking at a graph of an analysis for it. So here we'll start by plotting our x and y, and we'll use Larue's favorite function. And we'll begin by plotting a point here, which we will call x, and this is at the y coordinate of f of x, and plotting a coordinate here, which we will call x plus h, and this h will become important later, and this will be at f of x plus h. And here's why it's important, is because the distance between x and x plus h is h. And then if we connect these 2 points, this gives us the slope of the secant line between x and x plus h. And if we compare it to the slope of the line tangent at x as an x's derivative, it's not a very good estimate. So here is where the formal definition of derivative comes in play. We will make h closer and closer to 0 and smaller, and this will then begin to bring our estimate, our secant line, closer and closer to the line tangent at x. And this gives us our formal definition of the derivative then, which is f prime of x equals the limit as h approaches 0, so as h gets smaller and smaller and closer to x, of the function f of x plus h minus f of x all over h. So again, just as a little recap, what this means is that as h gets closer and closer to 0, it'll give us a better and better estimate until it is the best estimate of f prime of x of the function. First, we'll begin by looking at a multiple choice question practice. And here's our multiple choice question, and here are the possible answer choices A through E that we are given. First, we'll be looking at the numerator of the fraction within the limit, and that's natural log of 4 plus h minus natural log of 4. And we can actually replace the 4 with an x just to show that we're plugging a 4 in for x, and then that would be natural log of x plus h minus natural log of x. And this will help us to more easily identify our formal definition of a derivative, the numerator for that fraction, which is f of x plus h minus f of x. And then if we look at the commonality between these two numerators, we can compare the f of x and the natural log of 4. And this will show us that f of x equals natural log of x, or in other terms, our parent function is natural log of x, and this will be where x equals 4. And remember again, this is our formal definition of a derivative, which is f prime of x equals limit of as h approaches 0 of f of x plus h minus f of x all over h. And by looking and comparing this to our practice question here, we can see that there is definitely a distinct commonality and relationship between them, which helps us to identify that this is the formal definition of a derivative. And that would mean that f prime of x equals 1 over x, as the derivative of natural log of x is 1 over x, and then when we plug in a 4, we get f prime of 4 equal in 1/4, and that would give us option choice B. And if you had a little trouble with this, or you couldn't fully identify the formal definition of a derivative right away, you can also L'Hopital this question, but you need to do it in respect to h rather than x, and if you need help with that, see 4.7. Next, we'll take a look at a possible FRQ, or a concept that can be applied on the FRQs. First, we're given a graph, and we're asked the question, is the graph of f differentiable at x equals 1? Explain why or why not. So upon looking at x equals 1, we do see that it's continuous. However, it's not differentiable as there's a cusp. But again, we can't say that there's a cusp, so we must explain why. So again, we know that f prime of 1 does not exist, but we must explain why. And we can do so by using the formal definition of a derivative. And here's the formula given here. But this will be at f prime of 1. So it'll be f prime of 1 equals the limit as h approaches 0 of f of 1 plus h minus f of 1 all over h. And again, this is just manipulation of the formal definition of a derivative. So we'll look at the derivative then of x of equals 1 approaching the left and the right side to explain that it's not differentiable. So as the limit as h approaches 0 from the left, also meaning that the derivative or the slope of the line on the left side of 1, which is this line here, is negative. And then if we look at the limit as h approaches 0 from the right, otherwise known as the slope of the line of the derivative of 1 on the right side, is positive. And we know that a negative doesn't equal a positive, so the slope from the left does not equal the slope from the right, and this is sufficient enough to explain why the graph is not differentiable at x equals 1. All right. Next, we'll be looking at another multiple choice question. And here's a question, and this is a piecewise function, and it's asking which of the following statements are true. And we have statements 1, 2, and 3. So first, we'll begin by looking at statement 1. And statement 1 says limit as h approaches 0 from the left of f of 3 plus h minus f of 3 all over h equals 2. And remember, if you've been paying attention in this video, this is the formal definition of a derivative. So we have f prime of 3. This is what it's asking, is f prime of 3. But this is where it's asking from 3 from the left side as it's h approaching 0 from the left. So what this means is this is our top function in the piecewise function. So we'll put this function here. We have f of x equals 2x minus 2. We'll take its derivative because it's asking for the derivative at 3. And we have f prime of x equaling 2. So if we plug 3 in for x, we'll get a 2. So this statement is true. And that would then disregard A and B as our answer choices, which leaves us with C and D. And remember that this is a multiple choice question, so we're going to be looking to save some time. So to save time, we'll be looking at answer choice 3, because if answer choice 3 is true, that means that D will be correct, but if answer choice 3 is false, that means that C will be the correct answer. So we'll look at choice 3 here, or statement 3. F prime of 3 equals 2. And since it's f prime of 3, we know that this will be asking us for the bottom function because it's where x equals 3. So we'll put up this function here. We have f of x equals 2x minus 4. Take its derivative as it's asking for f prime of 3. And again, if we plug in a 3 here, we will always equal 2. So that means that this statement is indeed true and leaves us with the correct answer being D. And that was the formal definition of a derivative, topic 2.2. And just remember, you guys rock, and you'll be able to rock out this AP exam.